Alright, in this video I'm going to introduce you to functions. It says here a function defines a correspondence. Another name for correspondence would be relationship. So correspondence or relationship between a first set called the domain and a second set called the range, such that each member of the domain corresponds to exactly one member of the range. Alright, so let's go ahead and break this down. First of all, I like to keep it simple, and the phrase I would encourage you to remember is for a function, each input has exactly one output. So that's the basic idea of a function. Again, there's these two sets. We'll talk about the domain and range, but this is what it boils down to. Each input has exactly one output. So let's go ahead and look at this is what we call a relation that shows a relationship between numbers. So notice we have the domain, which has 1, 2, and 3 in it, and the range 2, 4, and 6. And in this case the function is f. And notice that 1 corresponds to 2, 2 corresponds to 4, 3 corresponds to 6. So each of our inputs correspond to exactly one output. So this is a function. Alright, so let's look at notation here. So since I called this function the f function, we could say that f of 1 is equal to 2. Or when my input is 1, my output here is 2. So we could think of our domain values as inputs and our range values as outputs. By the way, we read this f of 1 equals 2. Notice it's not f times 1, even though it looks like that. It means f of 1 equals 2. So for the function f, that means 1 corresponds to 2. We know that f of 2 is 4, and f of 3 is 6. So the 1, 2, and the 3 here are what we call inputs, and they're part of the domain. And the 2, 4, and 6 here are what we call the outputs, which are part of the range. Let's look at another relation. So notice here 1 corresponds to 1, and 3 corresponds to 2, and also to 3. So notice that 3 is an input that has 2 outputs. But up above we said an input, or each input is supposed to have exactly one output. So for that reason, this is not a function. So basically, notice what we have here. F of 3 is equal to 4. Whoops, I need to fix that. That should say 2. And then f of 3 corresponds to 3. So here you have an input of 3 that corresponds to 2 different outputs. So again, this is the kind of thing that can never happen. You can't have the same input with 2 different outputs. Alright, so we have also some terminology down below. The domain is the set of all our x values, or inputs, and the range is the set of all our y values, or outputs. And we'll look at an example below. The other thing I want to point out, it says relations and functions are most commonly represented as sets of ordered pairs, graphs, and equations. So in college algebra, our main focus is going to be on graphs and equations, but we start with ordered pairs to get a basic idea of what a function is. Alright, so let's look at ordered pairs. It says to be considered a function, each x value is paired with exactly one value. Another way to say that is x can't repeat. So let's look at number 1. Notice none of the x values there are repeats. No repeated x values. So that's a function. Our domain is all our x values, which would be -12, -10, and 8. Our range would be all our y values, which would be 3 and 5. Now notice there's 2 points with an output of 3, or y value of 3. And we don't need to write 2 3s. We can just write 1. Now if you look at example 2, notice we have 2 points that have the same x value, so x repeats. This is where we have a problem, because notice f of 2 is 0 and f of 2 is also 6. So 2 is an input that has 2 different outputs. Again, this can never happen with functions, so this is not a function. Now, it is a relation, so everything we look at are what we would call relations, because we have this relationship between numbers, but what we're most interested in is relations that are functions. In this relation, the domain is going to be all our x values, and the range all our y values. All right, so in this problem, it was those 2 points, 2, 0 and 2, 6, that caused this to not be a function. I want to go ahead and graph this because I want you to see something here. So notice I plotted the point 2, 0 and 2, 6. What do you notice about those 2 points? Well, you can see that one is vertically above the other. And so anytime this happens, you're going to have 2 points that have the same x value. Notice in this case, they're both going to have an x value of 2 with different y values. And again, that's a situation where we have something that's not a function. So that's where this vertical line test comes from. It says a graph represents a function if no vertical line passes through more than one point on its graph. Notice it talks about the domain starts at the leftmost x value. So you look at the leftmost point and its x value, and then the rightmost x value, which will occur at the rightmost point, is the end of the domain. And let's see, for the range, we're going from the lowest y value to the highest y value. So first of all, let's look at number 3 in terms of whether it's a function or not. I want you to notice there's a lot of places where I could draw a vertical line and go through 2 points. So here's one example. So this is not a function. I'm going to go ahead and erase what I just did here. So this is not a function. It doesn't pass the vertical line test. There's a lot of places where it goes through 2 spots. And actually, I do want to mention one thing again about what we had here. These 2 points both have an x value of 0, but different y values. And that's always what's going to happen when we draw a vertical line through 2 points on a graph. It shows us that what we have is not a function. So this is how we use the vertical line test. Let me erase this. Now, as far as our domain is concerned, let's look at the leftmost point, and the x value there is -3. We've got our rightmost point, which is at 3, some number. All I care about is the x values, or the inputs. So you can see that our domain is going to go from -3 to +3. We're including those numbers on the end, the -3 and the 3, because those points are on the graph. So what I want you to understand here is basically what we're saying is if you look at all these points in between here, they have x values between -3 and 3. So that's domain. What about the range? So with the range, now we're going from the lowest point, which has a y value of -2, to the highest point, which has a y value of 2. And so our range is going to go from -2 to 2. And again, what we're saying is if you look at all these points in between here, they have y values between -2 and 2. All right, let's move on to the next one. So first of all, this is a function. It does pass the vertical line test. You can draw vertical lines all over the place, and you're never going to go through 2 points. So this is a function. Let's look at the domain. Now first of all, notice there's you know, on the left and the right, this thing looks, it's kind of hard to know if it stops or it keeps going. We can assume that it keeps on going. So if I want to find my leftmost point, as I go along this side here, notice it keeps going forever left. There is no leftmost point. Same thing happens as I go the other way. There is not going to be any rightmost point. And so our domain is going to go from negative infinity to positive infinity. We're basically hitting every x value on this graph, if you look at all the points on this graph. Because again, there's no leftmost or rightmost point. Let's look at the range. So we do have a lowest point, and the y value there is -3. And then this thing goes up forever, so there is no highest point. So there won't be no biggest y value. So our range goes from -3 to infinity. All right, let's move on to example 5. So first of all, this is not a function. I want you to notice right here, we have a problem. We're going through more than one point. There's a couple places where we can do that in this area. And so this is not a function. So notice it's just that one little area that you got to watch out for. Let's look at domain and range. So our leftmost point is right there, and it has an x value of -4. Our rightmost point has an x value of 5. And we're hitting all the points in between, so our domain will go from -4 to 5. Now notice I used an open or a parenthesis on the left. That's because of this right here. This is actually an open circle, which tells me that that point, -4, -5, is not actually on the graph. It's just all the points going right up to that point. And so we have a parenthesis. Now on the 5, notice here you have a solid point, and so we are including that y or that x value, which is 5. All right, let's look at the range. So we do have that that's also our lowest point there, and the y value is -4, and that's our highest point, and it's got a y value of 5. And so the range is actually the same as the domain. Now that's a coincidence. That's not normally how it works. All right, let's move on. It says to determine whether an equation represents a function, solve for y, then determine if each input corresponds to exactly one output. So in each of these problems, we're going to start by solving for y. So on part A here, we need to subtract 5 on both sides, and we're going to get y equals 3x squared minus 5. So this turns out to be a function. So again, I want to see if each input corresponds to exactly one output. So think about this. If I plug in 0, for example, for x, y is going to equal 3 times 0 squared, which is just 0 minus 5, and you get -5. No matter what you plug in, you're going to square that number, multiply by 3, and subtract 5, and you're going to get a single number. And so in this case, for each input that you plug in, there's exactly one output. You're never going to get two answers when you plug in an input. All right, and you might think, well, that seems like, isn't that the way it would always be? Generally speaking, yes. You almost have to get creative to get something that's not a function when it's in equation form like this. So that one is a function. Let's look at B. So I want to get rid of the x first. We're going to get y squared equals x plus 4. And remember, if I want to get rid of that square, the 2 there, I've got to do the opposite of squaring, which is taking a square root. So we're going to take the square root of each side. You got to remember to do that plus or minus thing. So you're going to get y is equal to plus or minus the square root of x plus 4. So it turns out here we have a problem. Notice if I plug in 0 at plus or minus 0 plus 4, which is plus or minus the square root of 4, which would be plus or minus 2. So when I plug in 0, the input 0, I get two outputs, 2 and negative 2. And in fact, you're going to get two outputs in many cases here, so this is definitely not a function. So for each input, there are two outputs. In general, we actually could have an issue with the square root of a negative, or if we plugged in, let's see, if we plugged in x equals -4, we would have 0 under the square root, and so we would only get one answer there. But there's many cases where we're getting two outputs, so this is definitely not a function. So anytime you have a situation like this, you're not going to have a function. All right, let's talk about function notation. So we have some old notation that we use for graphing. If you have an equation like y equals 2x minus 3, in the good old days when we first started dealing with equations like this, we would graph by starting with an xy chart. And we'd pick values for x, like if you plug in 0 for x, y is going to equal 2 times 0 minus 3, and you get -3. Or if you plug in 1, y will equal 2 times 1, which is 2, minus 3, and you get -1. Or if you let x be 2, you get y equals 2 times 2 minus 3, and there you're going to get 1. So this corresponds to 3 points. And we could graph the points. Notice each point, I will remind you, has an x and a y value. That the first value is the x value, the second value the y value. But also I want to point out that we call the 2 an input and the 1 an output, because we were inputting values for x and then we were getting an output. So it's very similar to what we were doing with functions. So let's look at function notation. So now everything looks exactly the same here, but we're replacing y with a different notation, the function notation. Basically, this notation has a lot more flexibility, and we can do a lot more things with function notation. So in this case, let's say I plug in 0, then I'm going to get 2 times 0 minus 3, we get -3. If we plug in 1, it'll be 2 times 1 minus 3, and we get -1. If I plug in 2, I'm going to get an output of 1. So my inputs are 0, 1, and 2, and my outputs are -3, -1, and 1. And I hope you're seeing a pattern here. Notice that over here, 0, 3 is on the graph, and we got f of 0 equals -3. So I have an input of 0, an output of -3 in both cases. And similarly, on the other two cases, another example, 2, 1, if I plug in 2 into my function, I get an output of 1. So really, we're just getting the same information here, we're just using two different notations. So what this tells me is if you have f of 0 equal to -3, then we actually know a point on the graph, the point 0, -3. Or f of 2 is equal to 1 tells me that 2, 1 is a point that's on the graph of the function f. So I want to just make a couple comments here. So first of all, number 1, this is read f of x. It does not mean f times x. So you just have to get used to the notation. This is not multiplication here. The function is called f. X is the input, and f of x would actually be the output, or another name for y. So f of x is another name for y. Another thing we talked about is if f of a equals b, then a comma b is on the graph of f. It's really important that you understand this. Anytime you have f of some input equals an output, you also know a point on the graph of the function. And finally, just to keep things clear, we tend to use f, g, and h when we're doing function stuff, so that way we're not confused with the notation, and when we're dealing with functions and when we're not. So I'm going to go ahead and stop this video at this point. It's getting long, and I'll do a part 2